Today's lesson is a refresher lesson all on elimination, which is a method that you did learn last year for solving systems. And the goal of today is just to bring back all of that knowledge. Now, elimination is also called linear combination. So you may have heard it called this instead. So if you want to add that name, linear combination means the same thing. Elimination, linear combination, they're both the same concept. To get our thinking started, we're going to look at a couple of warm-up questions. What does it mean to eliminate something? In the real world, if something is eliminated, what does that mean? Eliminate, as you're thinking, I'm hoping either of these two ideas comes to mind. Eliminate means to get rid of, or make something go away. Make it go away. And the second question is, what does it mean to combine two things together? To combine is to put things together. And again, these are very informal definitions. Put things together. By the time we're done today, the goal will be to make a connection between why we can call this elimination, which means get rid of something or make something go away, and why this same method can also be called linear combination, where things are put together. Now, I'm sure you noticed this picture of Tetris. I hope it's a game we've played at some point in our life. If not, a quick overview of how the game is played. You move pieces left or right, and you can rotate the pieces so that they fit, and the goal is to make a complete line where all of these blocks are in a line and they get eliminated. So a quick summary of playing Tetris. We move terms around, move terms or pieces, move pieces around. Get them lined up. So a row can be eliminated. And this concept of moving pieces around, shifting them left and right, or even turning them around, will actually connect to our method. So bear with us, or bear with me as we talk, and we'll see how this game connects to today's lesson. Next it says, we're going to think of solving systems of linear equations using the elimination method or by linear combination. Remember, those mean the same thing, like playing Tetris. So our goal will be to eliminate one of the two variables so we can that says can, so we can solve for one of them. Then go find the other one. So our goal will be to eliminate one of the two variables so we can solve for one of them, then go find the other one. If we were to summarize the entire method in one sentence, one very informal sentence, that's how we would say it. Let's actually try this one together and see how it'll work. Example 1 says, solve the following system using elimination. We're actually going to think of this system as literally being on a game board. And this game board has 6 boxes. Notice that each term is in its own box, and the sign, like this plus 3y, the plus is inside the box with the 3y. Just like yesterday where our initial steps had a lot of words, I'm talking you through it so you can reference this at any time in your notebooks, and hopefully the conversation that are in the notes will help. And as we progress through the notes, you'll see less and less words written down. So step 1 says, rearrange each equation so that the like terms are lined up. Well, what do we mean by that? If we were to take colors, we're going to be using 2 highlighters, 1 or 2 highlighters. I'll actually try to stick with 1. Let's just say 1 color, okay? So if I highlight 4x in this game box grid, what else is like 4x? I have this positive 2y. The first step was to rearrange so that these are lined up. Are these lined up right now? Are these x's lined up? No, they're not. So we'll leave the top equation alone. And we're going to rearrange the second equation. I want this positive 2x to come first. So it's going to be positive 2x minus 3y. Notice how I was very careful to keep the negative sign in the box. Now if I check, notice my x terms are now lined up and my y terms are now lined up. If you're using 2 colors, you could maybe put this in green or pink or your other color. Otherwise, we'll kind of treat like no color as a color. So my x terms are lined up, my y terms are lined up. So step 1 is accomplished. We have rearranged so that like terms are lined up. Step 2 says, add the equations together. The like terms that are inverses of each other cancel. Let's see what that actually means. So notice we've put a plus sign in this line. Put a line down your equal sign, please, your equal signs. 4x plus 2x, I can do that. These are like terms. Positive 3y plus a negative 3y. Those will cancel because they are inverses. An inverse means that they're the same number, just opposite signs. So these cancel, they equal 0. So this becomes 6x equals 16 plus 8. 16 plus 8 is 24. And now look what we can solve for. Divide by 6, divide by 6. X equals 4. Step 3 says, substitute the values you just found into one of the original equations and solve for the remaining variable. We need to do that because we have x, but we don't know y. So it doesn't actually matter which equation you choose to come back to. So I choose the first one. So I'm going to rewrite 4x plus 3y equals 16. (4x plus 3y equals 16. And where I see x, we're going to substitute in 4 using parentheses. Solving for y, 4 times 4 is 16. plus 3y equals 16. We'll subtract 16 from both sides. Three y equals 0. Divide by 3. Divide by 3. Y equals 0. So my solution, as an ordered pair, is 4, 0. So just like in Tetris, where you can move pieces left and right, we were able to rearrange an equation, move 2x to the left in this case, so that my like terms would align. Once I had an alignment, if I have inverses present, like I did right here with the positive 3y and the negative 3y, these canceled. So just like in Tetris, where a row of pieces deletes itself, right, goes away. Here, the y terms canceled out, and I was immediately able to solve for x. We got x equals 4. We took that value, substituted into one of my original equations, and solved for y. Example 2. Notice our steps are still here written out, but kind of all up top. So all of our work is going to be in this blank space. Even though I don't have the grid, I still want you to see each of these as like a game piece that we can rearrange. Rearranging is a key part that we need to remember with elimination. So step 1, rearrange. Let's check. Are my like terms lined up? No. So take your highlighter and let's designate either x or y to be yellow. I'm going to say x is yellow. Notice how I highlight the sign as well. This plus sign belongs to the 3x. I need these yellow pieces, my x's, to be lined up. So I'm going to choose to rearrange the first equation to make that happen. I'm going to say 3x minus y equals 10. And the second equation I leave alone. I've successfully rearranged my system. Let's check. Are my like terms lined up? Yes, they are. Now that my like terms are vertically aligned here, x's are one on top of the other, the y's are lined up, we're ready to add. So we're going to draw a line down our equal sign and a line across and put a big plus sign out front. We are ready to combine. We're going to add these together, combine these two equations together. 3x plus 2x is 5x. And check this out. We have inverses again. A negative y plus y is 0. These cancel out. 5x equals 15. I can now solve for x in just one more step. Divide both sides by 5. X equals 3. We have x, we're halfway there, we need to find y. To find our y value, we're going to do our final step of substituting that value back into one of the original equations. Again, it doesn't matter which one we choose. I'm going to choose to avoid the negative if I can. This one, there's no negative, so I'm going to be choosing this one. You would still get the same answer. So if you want to try plugging into the top one, go ahead. We should get the same answer for y. So I'm going to rewrite my equation. 2x plus y equals 5. Line down the equal sign. Plugging in x equals 3. So 2, and then in parentheses, where I see x, I'll plug in, substitute in a 3. Plus y equals 5. This is 6 plus y equals 5. Subtract 6 from both sides. Y equals, let's see, 5 minus 6 -1, and I'm done. So as a solution, as an ordered pair, my solution is 3, -1. I'm done. Now notice, example 3, there's no writing. We're on our own to mentally keep track of the process. We just have this one little reminder to get us started. The directions say solve using elimination. And notice, check, are the like terms lined up? If not, rearrange. So let's get our highlighter, and we'll stick with x being yellow. So I have a positive 5x here, and then I have negative 5x over here. Are these lined up? No. So let's rearrange. I'm going to rearrange the top equation. So 5x plus 9y equals 29. And I'll choose to leave the second equation alone because now my x terms are lined up. So nothing happens, no rearranging the second equation. Now that my like terms are aligned, let's see. Do we have inverses? Yes. 5x and a negative 5x will cancel immediately. So I can draw lines on my equal sign, put a big plus out front. 5x plus a negative 5x cancels. These are inverses. They're exact opposites of each other. Combining the rest, 9y plus a negative 8y, or 9y minus 8y is y, equals 29 minus 23 is 6. No division was needed because when I combined, right away I got a single y. So y equals 6. We have found y. Now that I have my y value, I'm going to choose which equation do we want to substitute in to find x. Again, if I can avoid negatives, I choose to. If you like negatives, feel free. Choose the second equation. I'm going to work with the first one. Either way, we should get the same answer. Line down my equal sign. I have a value for y. So where I see y, in parentheses, I am going to substitute in a positive 6. Bring everything else down. Plus 5x equals 29. Pause and finish solving for x, please.
Oh, yeah, that.
9 times 6 is 54. Plus 5x equals 29. Subtracting 54 from both sides. Oops. The 54s cross out. That's 0. They cancel out. I bring down my 5x. Keep this line going as far as you need it to keep your equal signs lined up. This will get me 5x equals 29 minus 54 in your calculators. We get negative 25. Divide both sides by 5. X equals negative 5. My solution is x comma y. Here's x, so negative 5 comma y, which is 6. Start taking a look at example 4 and read these questions. For me, these questions are in yellow. I know on your photocopy they're gray. But take a look at these questions and see what you think. The question on the side says, do we have inverses present? Remember, inverses means exact opposites. Like 3 and -3. They're the same number, but opposite signs, so they're exact opposites. Do we have anything like that? Well, let's highlight our variables first, just to make sure we're lined up. So when I look, x, and here's my -3x, these are exactly aligned, so I'm good. But I need to check. Do I have inverses? Don't write this down. I want to show you what would happen if I just straight up try to add. Do not write this down. Watch what happens. What is x plus a -3x? That's a -2x. -y plus -y, that's -2y. Did anything cancel? No, nothing canceled. So I was able to linear, and I can keep going, -13 plus 11, -2. I was able to linearly combine these, but it got me nowhere. It got me nowhere because I don't have inverses. The key word is I don't have inverses yet. Do I have something that's close? So the answer to this is no, we don't have inverses yet, but we're close. Does anybody see where we're close? No, but we're close. Have 2 negative y's. See that here? We have 2 negative y's. So they're the same value, 1y and 1y, but right now they're both negative. Can we use multiplication to get one of these to be positive? We're going to multiply one of these equations all by -1. It does not matter which one you choose. I'm going to choose to multiply the top one. Now the key is that we're multiplying the entire equation by -1. Notice how I put the entire equation in parentheses and a -1 out front. This system will now become -x plus y equals 13. Because -1 times x is -x. -1 times a -y makes this become a positive y. And then a -1 times a -13 is a positive 13. We are going to leave the second equation alone. Not going to touch it. Because now when I look, I have my inverses. So we accomplish this by multiplying multiplied one of the equations by -1. So the answer to can we multiply one of the equations by a number that will make inverses be here? Notice that word make, like force them to be inverses? Yes. We accomplished that by multiplying one of the equations by -1. Now let's see what happens when we linearly combine these equations. -x plus a -3x, or -x minus 3x, is a -4x. Positive y and a -y cancel. That is 0. These are inverses, exact opposites. So we get -4x equals 24. I can now finish solving for x by divide by -4, divide by -4, and we get x equals -6. Now that I have x equals -6, what do we still need to go find? Need to find y. To make that happen, we're going to substitute into one of our original equations. This one or this one, the original equations. I am going to choose the first one. You could choose the second one. If you want to choose the second one, go for it. We'll get the same answer. I'm going to choose the first one. X minus y equals -13. Where I see x, I am going to substitute in negative 6. So I have negative 6 minus y equals negative 13. To solve for y, I'm going to add 6 to both sides. Line across. That's gone. Keep this line going. So I have negative y equals, what's negative 13 plus 6? Negative 13 plus 6 is a negative 7. Question, am I done? Is this all set? No. Because of this negative out front, I know that I need to finish this off by dividing both sides by negative 1. And now we're good. Y equals 7. So my solution is negative 6 comma 7. Let's say I wasn't sure if this was right. Let's run this through a check just in case. So we're going to use this for x and this for y. And remember, we do a check by rewriting our original equations. So check. So x minus y equals negative 13. And then negative 3x minus y equals 11. We're going to do them one at a time. So where I see x, I'm going to plug in negative 6. And then where I see a y, we're plugging in 7. Notice I'm very careful to use parentheses. And this should equal negative 13. Let's see. Negative 6 minus 7 is negative 13, equals negative 13. Check. That worked. Let's come over here. This will be negative 3, and in parentheses, I'm substituting in negative 6 minus 7, in parentheses, equals 11. Negative 3 times negative 6 is a positive 18, minus 7 equals 11. 18 minus 7, 11. 11 equals 11, check. So this is just a reminder that checking a point works the same way as it did with substitution. Take the point you think is your ordered pair, substitute it back into your original system. Both have to come out as true statements. If that happens, you are guaranteed 100% accuracy. You are 100% correct. Now, if you notice, example 5 says you do. So this will be the homework that is done tomorrow in class as practice. So anything marked you do, I will not be doing as part of the lesson. That will be what we work on tomorrow in class. Example 6 is a we do. So start taking a look at example 6. We don't need to necessarily answer these underneath anymore, but keep these as guiding questions, okay? Let's first check. Is there any rearranging needed? Well, I look, negative 8x and x. Those are lined up, so I know I'm all set. So next, let's think. Do we have inverses present? Well, this is a negative 8x. So for this to be the inverse, it would have to be a positive 8x. That's not the case. For my y's to be inverses, I would need a negative 5y and a positive 5y. I don't have that either. But can we make that happen? Yes, we can. What's the easiest option? Do we want to try to get inverses for x or inverses for y? Well, I already have this negative positive action happening here. Negative positive. This is negative. This is positive. So I'm going to choose to get inverses for my x values. To have inverses here, I need this to be an 8. To make that happen, I can multiply this entire equation by 8. We're going to leave the top equation alone. So this will stay negative 8x minus y equals negative 11. Let's see what happens with the second equation. 8 times x is 8x. 8 times negative 5y is a negative 40y equals, 8 times 27. Go ahead and use your calculator. 8 times 27, or do it off to the side, whichever, is 216. Now let's see. Do I have inverses? Yes, I do. Negative 8x plus 8x cancels. And now I have a negative y plus negative 40y, or you could just read it, negative y minus 40y is negative 41y equals negative 11 plus 216. In your calculator, negative 11 plus 216, or mentally, equals 205. In one more step, divide by negative 41, divide by negative 41. Doing that division, 205 divided by negative 41 equals negative 5. I've got y, I need to go find x. To make that happen, we need to choose one of our original equations. I choose to use the second one. X minus 5y equals 27. I have something to substitute in for y. So this will be x minus 5, and then in parentheses, I'm substituting in a negative 5 equals 27. This becomes x plus 25 equals 27. Subtract 25 from both sides. X equals 2. And I'm done. My solution is 2, comma, negative 5. Example 7 is a you-do question. So we're going to jump over to 8 and 9, both of which are special cases. So let's see what special cases we'll have here. First, I need to check, are my like terms lined up? Well, positive 8x is over here, and I've got a 16x here. Are these lined up? No. So let's line up our terms. I choose to rearrange the first one. So that will be 8x plus 5y equals negative 8. I can leave the second equation alone. 16x plus 10y equals negative 16. Let's check. Are we all set? Here's 8x, here's 16x. Yes, my x's are lined up, my y's are lined up. Do we have inverses present? That's the next question we're asking ourselves. Well, this is an 8, this is a 16. No. This is a 5, this is a 10. No. I need 5, well, I can't make 10 be a 5. But I can make 5 be a 10. And 8 could become a 16. So make a choice. Do you want x's to cancel or y's to cancel? I'm going to choose my y's. I would like my y's to cancel. So if this is a positive 10y, I need this to be a negative 10y. To make that happen, what do you think we're going to multiply by? This is a 10y. I need this to be a negative 10. Well, to get negative 10, I need to multiply 5 by negative 2. And if I need to multiply this by negative 2, I have to multiply the entire equation by negative 2. So let's see what happens. Negative 2 times 8x is negative 16x. Negative 2 times a positive 5y is negative 10y. And negative 2 times negative 8 is a positive 16. Leave the second equation alone. Don't touch it. And now let's combine. Let's linearly combine, because now I have my inverses, negative 10y and a positive 10y. Adding these together, let's see what happens. Uh-oh. Well, let's see. Negative 16x plus 16x, that's gone. That's 0. Negative 10y plus 10y, which were the inverses we were looking for, that's gone. That's 0. So on the left side, I have 0. What happens on the right? 16 minus 16, also 0. 0 equals 0. True or false? True. True statement. From yesterday, we know that that means I have one line graphed exactly on top. That's not exact. Let's make that exact. Exactly on, nope, still not. That's better. One line right on top of the other. Who remembers what that's called? They're the same line that is infinitely many solutions. Infinitely many solutions. True statement, same line. Same exact line. Meaning there's infinitely many points that work because this line goes on forever and ever in both directions. So this is what happens. This is what we're going to see happen when it's infinitely many solutions. I get a true statement, 0 equals 0, or 5 equals 5, something like that would be true. Let's take a look at number 9. First, let's check, are my like terms lined up? Here's 4x, negative 2x, yes. Do we have inverses? No, because this is a 4 and this is a negative 2. I would need a positive 4 and a negative 4. Here I have negative 20y and a positive 10y. For my y's to be inverses, this would need to be a negative 20y, and I would need a positive 20y. So no, there are not inverses. But can we make that happen? Yes, we can. Make a choice. I think I want my x's to cancel this time. So if this is a positive 4x, we said this needs to be a negative 4x. I can accomplish that by multiplying through by 2. So let's see. We're not going to touch the top equation, so 4x minus 20y equals 0. And the bottom equation becomes negative 4x plus 20y equals 4. Let's see what happens. 4x minus 4x is 0. Wasn't planning on those x's canceling, but they did. Okay. And then, well, no, I take that back. I wanted my x's to cancel. Those are my inverses. Scratch that from the record. So these canceled because those were the inverses I was shooting for. But look what happens with the y's. These cancel too. Negative 20y plus 20y is 0. So I've got 0 equals, what's on the right? 0 plus 4 is 4. True or false? Does 0 equal 4? No, it does not. False statements. From yesterday, if I get a false statement, what does that mean? Parallel lines. Will these lines ever intersect? No. No solution. So if we get a false statement, just like yesterday, if we got a false statement, it means no solution. We've got 10 and 11 as you-dos. See? You do, you do. That'll be for tomorrow. Example 12. Where are we at for time? I'm at 39 minutes. I'm going to stop here. Example 12 is technically a we do, but I'm going to make this a you do for tomorrow's class. And I'm going to challenge you to think about what's going to have to happen here. Remember, this is technically prior knowledge from last year. So can we think, now that we have warmed up our brains, we're remembering how elimination works, what's going to have to happen for 12 to be solved with elimination? Nice job, folks. I will see you tomorrow, and in class we will continue our practice of elimination. Have a great day.